So for question 5, we've been given two functions, f of x and g of x. We are told that they intersect at 2 points, and one of those points is C, which has the coordinates 5 and 12, and then f has a turning point of D, which has coordinates 3 and 16. The first question is asking us to determine the value of C for the graph g of x. We are given that the function of g of x has the equation -1/5x plus c. We're going to use the coordinates of c to find our small c, where 12 -1/5 multiplied by 5 plus c. 12 is equal to -1 plus c is going to 13. The second question is asking us to determine the equation of f of x by finding our a, p, and q. F of x is given by plus q. We already know that the turning point coordinate of our f of x, which are the coordinates of d, 3 and 16, so we can substitute them here, 3 and 16. We can now find out the value of a by using the coordinates of c. So the coordinates of c, for y we have 12, x we have 5 minus b squared plus 16. Minus 16 is going to be -4. That's going to equal 8 divided by 4 divided by 4. 8 is going to be -1. The next question is asking us to find the equation of k of x, which is a line perpendicular to the g of x function that passes through E. We do know that if two straight lines are perpendicular to each other, the product of their gradients is going to be -1. So m1 times m2, -1, we already have the -1/5 times m2 is equal to -1. So our m2, our second gradient, is going to be +5. So k of x is equal to 5x plus c. How are we going to get our c? Because we do know that our k of x is passing through E, which is also a point that f of x passes, we can first find the coordinates of E by using f of x. So f of x, we do know that at this point x is equal to 0, so it's going to be 0 minus 3 squared plus 16. This is going to be 9 plus 16, 7. Therefore, our coordinates of E are 0 and +7. Substitute these values here. We have 7, 5, and 0 plus c. C is equal to 7. Therefore, k of x is equal to 5x plus 7. The next question is asking us to find values of x that will allow f of x to which f of x is greater or equal to k of x. Okay, f of x is greater or equal to k of x. What we're going to do is substitute with the equations. X minus 3 squared plus 16 is greater or equal to 5x plus 7. This is going to be x squared minus 6x plus 9 plus 16 x plus 7. This should be the negative x squared plus 6x minus 9 plus 16, 5x plus 17. On this side, we're going to be left with, this is going to give us +7, 5x plus 7. We take these two onto that side, we're going to be left with -x squared. +6x minus 5x is going to be plus x. +7 minus 7 is going to be 0. So we're left with this. We have a common factor. We have a common factor. We have that x plus 1. So we're going to have x where x is greater or equal to 0, or a negative x plus 1 greater or equal to 0. Take the 1 to that side. We don't want a negative x divided by negative 1 divided by negative 1. In inequalities, whenever you multiply or divide by a negative 1, your sign change. So initially you had greater or equal to, now we're going to have less than or equal to 1. So the values of x that will allow, for which the f of x is greater or equal to the k of x function are values that are x values that are less than or equal to 1, greater or equal to 0. It is now given that the h of x function is equal to 2 the power negative f of x. We now need to find the minimum function of this. We do know that the maximum value of the f of x function, the y value, is 16. The maximum value of this is going to be 16. H of x, to get the minimum value of the h of x function, we just need to substitute this 16 into this function to get the minimum value of h of x. We substitute the maximum value of the f of x function. Then we get, if we get 1 over 2 to the power 16. This value is the minimum value of the h of x function. The last question on this section is asking us to find the average gradient between the values where x is negative 3 and x is positive 1. The first thing that we're going to do is find the y values of the corresponding x's.